Hey, good morning, hackers. My name is Paul Burbage, and today I'll be presenting on Illuminating Malware Adversaries with MalBeacon. Really excited to show you a passion project that I've been working on for over 3 years now. So let's go ahead and dive in. A little bit about myself. I'm a malware researcher, and my passion in the field is taking a look at those malware families that utilize PHP web application and finding vulnerabilities within them. I'm a drummer and, of course, like music. And I was active duty Marine 2004 to 2008. Any devil dogs in here? Yeah, all right, Semper Fi, brothers. Semper Fi. Good to go. How about the other branches? Army? I know Army's, oh, there's my holes. Navy, Air Force? Nobody? Who am I leaving out? Space Force? Nobody? All right. Thank you all for your service. Feel free to reach out to me on the Twitter sphere there. I'm at Hexlax. All right, so we'll go over our agenda for today. I'll discuss what I foresee is the a problem within the malware ecosystem. It's far too easy for anyone to go out and grab a malware kit and utilize that to breach an organization. To understand how the system works, I'll briefly touch upon what is stored cross-site scripting, and then dive into the system itself. How we're able to inject payloads within malware situ and receive those callbacks from the actors as they log in to administer those botnets. Briefly touch upon the legality concerns with this system, and then I also have some case studies to present to you. Finally, wrap that up with conclusion and Q&A. So, as I stated earlier, it's far too easy for anyone to go out to the internet, whether that be on the open internet or within these vetted forums, and acquire malware kits, not only for purchase, but some of them can be obtained for free. And in my opinion, the current attribution for this is one-sided. It's typically grouped by infrastructure, as well as similar tools, techniques, and procedures, or shared malware code. So we need to have better attribution, to defend our networks, and one way that we can do this is to beacon adversaries as they utilize their malware command and control. Briefly, just touching upon what is stored cross-site scripting. Cross-site scripting in general is just whenever a web app vulnerability allows an attacker to execute script. It's actually the most common web app vulnerability today. Even more so in malware C2, right? Because those malware kits, they're not going to go through, hopefully, the rigorous testing that a legit software company would be going through. Stored cross-site scripting is persistent, so we can store our payload usually in the database, but it can also be stored, within a file on the web server or within session information. So whenever that data is stored, then presented to the web application user. In this case, it's going to be the malware actor who's conducting those campaigns, and it's not sanitized properly on the output of that, so it renders either HTML or JavaScript. And although it is possible to inject JavaScript into these malware C2s, for this particular system, we're solely using benign image callbacks, and I'll discuss that here in a little bit as we discuss the legality concerns. So to understand what a malware C2 is, command and control, I like to think of it having two interfaces. So all of the infected computers typically communicate through what you can think of as an API, commonly referred to in the underground vernacular as the gate. And then the adversary is able to control those computers, issue commands, or receive exfiltrated data from those infected computers through the admin interface. For this system, we're solely inserting beacons through the C2 API, so the gate, as if we were an infected computer. As that administrator, the malicious adversary, logs in, they might be greeted with a screen like this. So this is a screenshot of form book malware. As you can see down at the bottom, there's 2 lines indicating that he has 2 victims. Some of those fields indicating like the machine name, so that particular field might be one of those fields that are able to be injected with HTML callbacks. Let's dive into the system itself. So again, we're using stored cross-site scripting to insert beacon payloads. And we can do that via two methods. Manual insertion, where we actually write a fake bot to check in with the C2. And we also can utilize an automated sandbox to run several samples through. And I'll go over what that looks like here in a little bit. And then when that callback occurs, whenever the malicious individual logs into the C2, we're just going to receive that image request and log everything. I'll go over what this looks like. So the manual injection method, this requires us to analyze the C2 source code. So we have to have a copy of that, right? Find stored cross-site scripting flaws within the code. And not only that, but reverse engineer the bot check-in protocol to write a fake bot to insert that beacon. So the pros is, it's very sniper-like precision, which leads to a high beacon callback rate. But with the cons of that, it's very time-consuming. And as you can imagine, if the malware family is under constant development, you have to go back to the drawing board and reverse engineer that malware to rewrite the bot check-in code. But we also have the automated method. Show of hands, who here has heard of Cuckoo Sandbox? Cool, quite a few of you, all right. For those that don't know, it's an open source software written in Python. It just allows you to execute malicious samples within a virtualized environment, right? So what we did with Cuckoo is that we've monitored the DLL that gets injected into the malicious process as that malware samples ran. And in the event that, say, the malware sample says, give me the machine name or the username that I just infected, we hook that API call, and we're able to take the response to that with our beacon injection payload. So that from there, that might be one of the artifacts that are, again, submitted up to the C2, and then hopefully it's vulnerable to stored cross-site scripting. The malware actor logs in and fires a call back to us as far as who's utilizing that malware C2. So the pros of the automated injection is that it's very scalable, right? We can scale out our sandboxes to pump hundreds, if not thousands of samples through. It's cool that it's not affected by malware changes. One of the case studies I'll go over, Kpot info stealer, one of the families that were susceptible to this method, it was under active development, and the authors were changing the bot check-in protocol usually about once a month or so. Even though they were changing that and we had manual injection bots, we could still get beacons out of that with fresh samples, just tossing them into our automated sandbox hook there. So it does cast a wider net, and it's more or less like a spray and pray method, which can lead to OPSEC concerns. Why is that? Well, best case scenario that a malware family is not susceptible to beaconing, that C2 is just going to drop the malicious request, the bot request. But worst case scenario, we submit a beacon and it's not rendered properly, it's not rendered as HTML, they would be able to see that callback, to our system with our domain information and whatnot. So obviously a operations security concern. Let's go over the receiver. So as the receiver is just receiving these image requests, essentially just log it. I'm doing that is just everything cool with the projector. All right. The way that we're doing that is just some HT access tricks. So any type of image request comes, we redirect that to a PHP script and then log everything. When I was first looking at this, I was really surprised about how much information you can get out of just an image request. It really opened my eyes up to all of the information that, say, like an advertisement company was recording on each and every one of us. So what do we get from that? We get the source IP address, the HTTP referrer field, probably the most interesting. This is going to be the URL where the adversary is currently logged into, being the C2 URL. In some of the manual injection methods, we're able to submit a UID. This is really cool when some of the malware families, they might have multiple proxies in between what the infected computer communicates with and what the administrative malicious individuals logging into. So we're able to see beyond that whole proxy infrastructure to the actual back-end C2. Then with some of these, free HTTP proxies, some people think that they might be, hiding their true IP address. They actually submit a proxy header within that same request. So if we see that, we log the true IP address of individuals, utilizing those free proxies. And then the user agent of that request. Of course, all of these can be forged, but if the user agent's true, that tells us quite a good deal, bit of information about our adversary. Everything from their machine architecture, x86, 64-bit, whether or not they're coming from a mobile device, their operating system, and even their web browser preference. So the system, the receiver, records information, and then from there, just replies back with a 1x1 pixel image. Why do we do that? Because as long as it's properly rendered within the C2, we didn't want to mess any of the HTML formatting up. So just by delivering a 1x1 pixel, that image is rendered, and hopefully the malicious adversary looking at their C2 is none the wiser that an image request is actually occurring on that screen. And then probably one of the coolest things, I was talking to some folks 3 or 4 months ago, and they had suggested, dude, why aren't you setting a persistent cookie in that reply? That way, if as long as it's the same browser session, and we set like a crazy expiration date for that the cookie, several years out, they can change the C2 URL, the domain, and we're able to group that to the same adversary. And even if the same adversary is utilizing different malware families, right? And that's exactly what I implemented. So I clustered 1 month of data here, and this is a clustering of the unique cookie IDs with the C2 domains. And what was really cool is that we were able to group 134 domains, which is essentially tracking that back to one threat actor group. So pretty cool information. And again, this was multiple domains and different malware families. So this particular threat actor group is very busy. So we should probably touch upon the legality of utilizing this. And I actually went through several rounds with the EFF, or the Electronic Frontier Foundation, and I wanted to get their opinion. What's the bounds as far as doing this within malware C2? And the word that I got back from them is, as long as you're not doing any type of execution, which in this case would be JavaScript, it's fair game. You can do benign image callbacks, which is pretty cool to hear. And this is no worse than ads utilizing images, right? I bet if each and every one of us pulled up our phone and looked at some of the, the raw text or source of that email, you're going to find these image callbacks, for opening emails and whatnot. Since we're not doing JavaScript, there's no authentication bypass, right? So we're not doing any type of cookie stealing. And it's privacy respectful, right? So these beacons are solely submitted through the infected computer protocol up to the C2, and casual people just browsing the internet, they wouldn't be tripping these beacons, by ordering stuff on Amazon or whatever. Good to go? Dive into some of the case studies here. So BlueLive, I believe, calls this group Air9, and Cisco Talos Group calls it TA545. And again, I've been collecting this data for over 3 years. Back in January of 2018, this particular group, they were utilizing the onliner spam bot to send malicious emails with CanadaPost.zip attachments. The zip contained a VBS script, which is a malware family called Ars VBS. So once that victim clicks on the VBS script within that zip, reaches out to the C2 here, the admin interface pictured right, and it asks the C2, what additional malware would you like me to download and execute? We call this a loader, by the way. In these campaigns, they were loading a banking Trojan that targeted Canadian financial institutions' customers, as well as Zero Evil Stealer. Zero Evil Stealer, also a malware family written by the same author as Ars VBS Loader in Russian underground forums. Pretty cool callback on this, traced it back to a dedicated server, Windows server nonetheless, in UK. So the Canadian CERT guys were pretty interested in receiving that bit of intelligence. For the second case study, this is an ongoing threat out there on the internet. So what the bad guys do, they'll take a look at popular crypto coin wallet software. They'll copy that site, stand it up, advertise it like on crypto forums, or just rely on search engine optimization. For unbeknownst victims searching for that software will get sent to the bad site, downloads malware. And in this case, back in September of 2018, they were downloading Kpot InfoStealer. It's a Russian InfoStealer sold in, again, the Russian underground forums. Kpot, by the way, is the Russian word, actually pronounced krot. It's the Russian word for mole. Some pretty cool callbacks on this, tracing back to a VPS provider in Russia. So this not only works with commodity malware that's sold or traded in the underground. This has also worked with persistent threat groups. Back in January of this year, a piece of mole rats malware came across my desk. So this is one of the ones that I tossed into the automated sandbox, it was able to hook some of the functions of the data that was exfiltrated from that the VM and got some callbacks on it. This was one of the malware families too that had multiple proxies in between the infected nodes and the actual malware C2. And when we get the callbacks, again with the HTTP referrer field, we're able to see that true admin interface that they're utilizing to, to control their botnet. Some pretty cool, attribution callbacks on this one. Again, mole rats being attributed to the Gaza cyber gang, and the beacons were geolocated back to the Gaza Strip. So pretty cool attribution there. Another cool thing with this particular beacon was that it was utilizing the user agent 2s. And in order to get that admin interface screen to show up, to access that admin interface, you had to set that as a user agent. So that was kind of like a unique hard-coded artifact, and by searching that particular user agent string across social media profiles, may or may not have found a couple people attributed to this group. Just wanted to briefly touch upon the current statistics of it. I've been running the system for a little over 3 years. We've enumerated 27,000 unique IP addresses from attackers, and the amount of beacons that we received, close to 350,000. Malware C2 unique domains or IP addresses, a little over 32,000. So it's just been a really fun project to work on. It's kind of a perfect marriage, or three-way even, between my passion for doing malware analysis, web app vulnerability assessment, and what's the third one? I can't remember. I'll come back to it. So in conclusion, I really want to scale out the sandbox system, right? Run, hundreds, but maybe thousands of samples through every day. From there, when we receive those beacons, you can then go back and target that particular malware family to write the actual manual injection bots by reverse engineering that particular C2 protocol. And then clustering out the beacons. If anyone's into like data science, I'd really like to talk to you about how we can cluster that information to attribute that and start grouping these threat actor groups. I think that's probably one of the cooler aspects of this particular data set. And then extend support with the sandbox to other operating system malware, everything from Mac malware to Linux, Android, list goes on. So currently right now, as you can see down at the bottom right of the screen, it's a bit.ly short URL. If you want to get access to the data, it's just an account, or the short URL goes to a Google form, not a Rickroll or anything. I just request some information to verify who you are, just to make sure I'm not giving out accounts to bad guys, but it'll allow you to search the data set if you're interested in that. And I'm currently working on like a feed and an API for people to maybe write like a Maltego transform, something like that. That's about it. Thank you. Wrap that pretty quick. Any questions, concerns? Good to go? Yes, sir. Initially, I didn't really go into, so the question was, what's been the hardest part of this whole adventure? It's I kind of had my hands tied behind my back with the feedback that I got from the EFF. Initially, I wanted to do full JavaScript injection, which, as you can imagine, you can get a lot of information just by a JavaScript inject. If anyone's ever taken a look at the browser exploitation framework, you can do everything from request webcam access and take pictures of people, behind their computer as they utilize malware situ. There's a company off the top of my head called SessionCam. So if you load their JavaScript, it records in real time a video of everything that's occurring within that web app on that screen. I wanted to do stuff like that, but yeah, unfortunately, only benign images, but still a good bit of information that you can get solely doing benign image callbacks. Any other questions or concerns? Yes, sir. Right. Yeah. Yeah, that's a good point. So it's all a matter of, excuse me, sourcing of that particular malware. So the malware that where I'm getting it is from public repositories like VirusTotal and whatnot. But you make a good point. So there has been some work done. I think they call it like deception technology, right? So you for example, like you have a decoy document on a Windows share within your organization that calls out in the event that document's opened. No business purpose for anyone to be accessing that. So if someone breaches your organization and you get a callback from that particular document, that's a pretty good sign that you have someone inside your network. Yeah, that's a little more along the same lines, but this is a little bit more proactive in that we're going after live malware samples in the wild. Yes, sir.
Have you considered getting with the people who have proper authorities and things like that? So talk to law enforcement, maybe getting to law enforcement tools if they have warrants and legal backing?
I can neither confirm nor deny. That's a good question.